Hello student, I am Dr. S. L. Munde, Assistant Professor, Department of Mathematics, Sri RLT College of Science, Akola. Dear student, in a previous lecture we have seen some examples on assignment problems. So that problem we have seen that problems were on the form of that is I think balance type problems. Okay, so in this lecture we will see another some examples of the form that is unbalanced type assignment problems. Okay, so in this lecture we will see unbalanced type as some examples on an unbalanced type assignment problem. So we will see the first problem, that is problem number 3. So we will see the first problem or serial problem number 3, unbalanced type problem. So how will you check the given problem is unbalanced type? Let us see with the help of examples. Okay. So solve the following assignment problem of the minimizing total time for the drawing all jobs. Here word is minimizing. That means we can say that this problem is the minimal type of the problem. So these are the groups of job 1, 2, 3, 4, 5, and these are the group of the man 1, 2, 3, 4, 5. Okay. So here the number of jobs is not equal to the number of man person group. Okay. So such types of problem is called as an unbalanced type problem. Okay, now we will see the solution of this problem. So write down the given assignment problem is, so write down this table is as it is. Okay, so here if you see the number of jobs are 6 and number of man groups are that is 5. That means we can say that the number of rows is not equal to the number of column, and hence we can say that so this problem is an unbalanced type, because here the number of rows is not equal to the number of column. That means em is not equal to n, and hence we can say that this is the problem of unbalanced type. Okay, now first we have to convert this problem in the form of balanced type. Okay, so for that we have to add one dummy column. For that we have to add dummy column, or we can say that zero column. Okay, so for that we have to add zero column, or we can say that dummy column. Okay, so this is the dummy column we have add in this table, assignment problem table. So now you have to check 1, 2, 3, 4, 5, 6. So these are the number of column is 6 and number of rows is 6. So therefore this is the problem of the balance type problem. Okay, now you can proceed uh, as usual of the balance type problem. Okay, so here number of rows equal to number of column, that means m equal to n. Okay, hence the problem is now the balance type problem. Okay, now we have to make the assignment. For that we want in each row at least 1 0 and in each column at least 1 0. Okay, so if you observe from this table, so there is at least 1 0 in each row. So first row, second row, third row, fifth row and sixth row, there is at least 1 0 in each row, because we have already add here 0 column or dummy column. So therefore in each row there is at least 1 0. Okay, so this steps will already we will skip here. Okay, now we want in each column at least 1 0. Okay, so in first column we want at least 1 0. So for that we have to subtract smallest element from each element. Okay, so here 2 is the smallest element, then we can subtract from this column. So we will get here 4 minus, that is 6 minus 2, that is 4. 2 minus 2, that is 0. Then 7 minus 2, that is 5. Then 6 minus 2, that is 4. And 9 minus 2, that is 7, and 4 minus 2, that is 2. Okay, so in this way we can find out the first column. Second column, you have to select smallest element, that is 2. So we can subtract this 2 from each element of the second column. So here will becomes 0, 3, 6, 0, 1, 5. Okay, similarly from third column, 3 is the smallest element, so therefore we can subtract from this element. So here will become 3, here 5, here is 3, here is 0 and here is 5 and 2. Okay, so similarly we can take two smallest number, then we will subtract. Similarly from this, here is 0, so therefore there will be no changes in this in this column, because there is already 0 in this column, therefore there is no need to subtract the smallest element. Okay, so in this way we can find out the we can obtain at least one zero for the each row as well as for each column. Okay, now if you observe in each row and in each column at least there is a 1 0. Okay, so if there is at least 1 0, then we can make the zero assignment, then we are ready to make the zero assignment where the at least 1 0 is present in each row and in each column. Okay, now we will go to row wise. In first row there are 2 or 3 zeros, so therefore we will skip this first row. Second row there are 2 0, again we will skip this row. In third row there is only 1 0, so therefore we can assign here 0, therefore we can assign here 0 and cross the first cross this column. Okay, in fourth row there are 2 0, therefore we can skip this. In fifth row there is a there are 2 0, therefore again we will skip this. In sixth row there is a 0 at this position, but at this position there is already cross, so therefore we cannot make here 0 assignment. Okay, now we will go to column wise. In first column there is a 1 0 at this cell, so therefore we can make here 0 assignment and cross this second row. Okay, in second column there are 2 0, therefore we cannot make here 0 assignment. In third column there is a 1 0, therefore we can make here 0 assignment and cross this fourth row. Similarly, in fourth column there is a only 1 0, therefore we can make here a 0 assignment and cross the first row. In fifth column there is a 1 0 at this cell, therefore we can make here 0 assignment and cross this fifth number row. And similarly in number 5 there is already 0 assignment, so therefore we cannot make here again 0 assignment. Okay, so if you observe here the number of line n equal to 5 and order of the matrix is n, that means here capital N is not equal to small n. Okay, that means this table will not give the optimal assignment. Okay, so to obtain the optimal assignment we will go to next step. So what is the next steps? So you have to select the smallest element from the remaining element, then you have to subtract this smallest element from the remaining element and add where the line is double cross and where the line is single cross, that element should be remain as it is. Okay, so you will get these steps. Okay, so here smallest element is 2, so we will subtract this smallest element 2 from this 5 6 3 7 2 5 2 4, and here we will add, here we will 2, here is 7, here is 9, here is 2 and here is 2, so in this way here is a 2, here is a 8, so in this way we will get this table. Okay, after subtracting the smallest element from each element. Okay, so you will get this table. Okay, now again we will make the 0 assignment to this table. We will go to first row wise. In first row there are 2 0, therefore we cannot make here 0 assignment. In second row there is a only 1 0, so therefore we can make 0 assignment and cross this first column. In third row there is a only 1 0, so therefore we can make here 0 assignment and cross this column. In fourth row there are 2 0, therefore we cannot make here 0 assignment. In fifth row there are again 2 0, therefore we cannot make here 0 assignment. In sixth row there is no 0, this is 0, but this 0 is already crossed, therefore we cannot make here 0 assignment. Now we will go to column wise. In first column there is already 0 assigned, therefore we cannot make 0 again. In second column there are 1 2 3 0, therefore we cannot make here 0 assignment. In third column there is a only one zero, therefore we can make here zero assignment and cross the fourth row. In fourth column there is a only one zero at this cell and cross this first row. In number E column there is a only one zero at this cell, therefore we can make zero assignment and cross this row number 5. And in number column F there is already zero assigned. So in this way we can make the zero assignment. Okay. Now we will check the number of lines, that is 5, and number of order of the matrix, that is n, and hence we can say that capital N is not equal to small n. So again here we have to select the smallest element from the remaining element, and that will be the 1. Okay, so this 1 we will subtract from the remaining element, add where the line is double cross, and the single line cross there, that element should be the remain as it is. Okay, so in this way we can obtain this table. Okay, adding and subtracting whatever the previous as usual method. Okay, so here if you observe from each row and each column you will get at least one zero. Now you can make the zero assignment in each row. First we will go to row wise. So in first row there are two zero, therefore we cannot make here zero assignment. In second row there is only one zero, therefore we can make zero assignment and cross the first column. In third row there is only one zero, therefore we can make here zero assignment and cross this column. In fourth row there are the two zero, therefore we can skip these steps. In fifth row there are two zero, therefore we again skip these steps. In sixth row there are again in sixth row there is a one zero. There is a one zero here. We can make here zero assignment. Okay, and we will zero assignment. We will cross this column. Okay, so in this way we will get the column assignment, row assignment. Now we will go to column wise. In first column there is already zero assigned. In second column, in second column, uh, in second column, in second column we cannot make here zero assignment. There are two zero, this zero, this zero. In third column there is already zero assignment. In fourth column there is only one zero, so therefore we can make here zero assignment and cross this row number 1. In column number A there is only one zero at this cell, so therefore we can make zero assignment and cross this row. In sixth column there is already zero assigned. So here the number of lines are 4 and order of matrix, that is 6. So therefore we can say that the order of the matrix is not equal to order of the number of the lines. So again we will select smallest element, that will be the 0. So if you add and subtract this 0 from the remaining element and from the double where the line is crossed, so there will be the no change. So again you will come back to these steps. Okay, so again you can come to these steps. So in this way we can obtain this table. Okay, so again you can go to column wise, row wise, column wise, row wise. So in this way you will get the number of lines, that is n equal to 6, and order of the matrix, that is n equal to 6. So in this way you can make the zero assignment in each row and in each column. And now if you observe, in each row and in each column there is at least one zero assignment. Okay, so here the number of line capital N is equal to small n. That means our problem is our assignment problem is here will be here assignment problem is finished. Okay, now we will find out the total assignment. So first column, first group assigned to the D group and number of person is 2. Second group assigned to A group and number of person is 2. Then third group assigned to F, number of person is 0, that is a dummy group. And fourth group assigned to B group, that is number of person is 2. And 5 group assigned to E, number of person is 0. And 6 group assigned to C, number of person is 5. Okay, so this is the total assignment. Therefore, the optimal assignment is z equal to addition of this term. So you will get 11 unit. Okay. So this is the examples of the unbalanced type of assignment problem. Okay. So in this way you can find out or you can solve the any types of the unbalanced type problem. So for that you have to add one dummy zero. Okay. Suppose here is a here is number of the column are 5 and a number of the rows are 6. So here you have to add the dummy column, and suppose here is a number of the rows is 5 and a number of the column is 6. So then in this case you have to add here one dummy 0 rows. Okay, so in this way you can make the unbalanced problem into the balanced type problem, then you can solve as usual method. So in this way you can solve any types of the assignment problem, whatever be the question, you can easily solve by using such types of methods. Okay, so I will give you one example to for the purpose of homework. Okay, so this is the one example, so you have to solve this example for the homework. So you can see how the example is solved by step. You can check, then you can solve in your notebook. Okay, so this is the one example to you. Okay, so you can check. Okay, so this is the uh, examples on unbalanced type problems. Okay, so in this way you can solve the any type of the question. Okay, so we will stop here. We will see next problem. Next problem will be the on the maximal type of the problem. Okay, so in next lecture we will see maximal type of the assignment problem.